Welcome everyone. Today's video is going to be an extension of our practical class from last week on spirometry, and of course is my first video. I am going to take you through several processes analyzing data on spirometry using PowerLab. I'm going to take you through a brief introduction on PowerLab. Then I will show you how to analyze data using PowerLab and how to extract information from our spirogram, the result we collected last week, and bring it into Word document and then tabulate your result, how to calculate some lung volumes and capacities using different formulas. Without any waste of time, we are going to delve into it right away. A brief word about PowerLab. In our last experiment, we used PowerLab for measurement of lung volumes and capacity, and the process is called spirometry. PowerLab can be used for diverse functions depending on the kind of experiment you want to perform with. So you can simply attach the accessory equipment required for that particular experiment. In our last experiment, we used pneumotachymeter or PowerLab spirometer. What is PowerLab? It's simply a data acquisition system comprising of hardware and software designed for use in life science research and teaching application. The purpose of the PowerLab is to acquire and store and then analyze data, and it is used in various fields like physiology, pharmacology, biochemistry, biomedical engineering, sport and exercise, psychophysiological signals even from humans or animal subjects or isolated organs or tissue. So, and there are research power labs and teaching power labs. They are of different types and of different versions. So the system consists of an input device connected to a Microsoft or Macintosh computer using a USB cable, and then it has that software called the LabChart software. Normally the hardware of this LabChart does not contain any button on it. It is being controlled through the LabChart software, and then it is supplied with the recording, display and analysis function. So that is the function of the LabChart software. So it records, it displays the inputs, and then it can also be used for analyzing the data collected. And that is what we are going to be doing today. I promised to show you how to extract some of the information from the data, and that is what I am going to be doing today. So this is a briefing of words about PowerLab. So now we are going to talk about how data is being acquired through the PowerLab. And on the diagram, you can see a pulse transducer attached to the finger there, which serves as an input where it will begin to, the pulse transducer is a kind of a sensor that dictates pulse from the finger, and that serves as an input. So first, a transducer converts the signal of interest like blood pressure or body temperature, depending on whatever you attach to the PowerLab, or ECG signal into an analog voltage whose amplitude varies continuously over time. This voltage is monitored by the recording hardware, which can modify it by amplification and filtering processes called signal conditioning. As you can see in the diagram, when the signal enters, it will amplify it and then filter it, and the process is called signal conditioning. So the signal conditioning may also include zeroing. Normally at the beginning of the experiment, we tend to zero all inputs. So, and also the removal of unwanted steady offset voltage from a transducer's output. So after signal conditioning, the analog voltage is sampled at regular interval. So the analog voltage will be sampled at regular intervals, as you can see the sampling here. So after sampling at regular intervals from a transducer's output, the signal is then converted from analog to digital form before transmission to the attached computer. The LabChart software usually displays the data directly. It plots the samples and digitize data points and reconstruct the original waveform by drawing lines between points. Digital data can be stored for later retrieval. The software can also easily manipulate and analyze the data in a variety of ways. Spirometry is the process of determining vital capacity, peak expiratory flow rate, and lung volumes and capacity. The instrument employed in the process is called spirometer, while the record or tracing obtained from a spirometer is called spirogram. Tracing obtained from vitalograph machine is called vitalogram. Volume changes are due to inspiratory and expiratory abilities of the lungs. Lung volumes refer to the non-overlapping subdivision or fraction of the total lung air, while the time capacities refer to the combination of two or more lung volumes or lung volumes which emanate from the size of the lungs and thorax. So this is the typical diagram of a spirogram, and here you can see the subject breathing normally at resting state, and here when we ask the subject to take in more breath to fill the lung at the end of a normal expiration and ask him to exhale completely, you will understand the concept of lung volumes and capacity and the difference between them when I explain furthermore on the spirogram. Inspiration is a positive deflection from zero line and expiration negative deflection from zero. We've got a positive inspiratory ventilation and a negative expiratory ventilation, breathing in and out in a cyclic manner. The lung volumes, the tidal volume is the amount of air inspired or expired during normal quiet respiration. So the amount of air forcefully inspired above and beyond normal expiration is called the inspiratory reserve volume, while the amount of air forcefully expired beyond normal expiration is called the expiratory reserve volume. So you can see from this point to this point. Here we have the residual volume. The residual volume is the amount of air remaining trapped in the lungs after a forceful expiration. So these are the four lung volumes that we are talking about. They are the non-overlapping subdivisions, while the capacities is the combination of two or more lung volumes. So the total lung capacity is the sum total of air the lung can contain. And then we have the maximal amount of air that can be forcefully expired after a maximal inspiration is called the vital capacity. Functional residual capacity, amount of air remaining in the lungs after a normal expiration. The inspiratory capacity is the maximal amount of air that can be inspired after a normal expiration. And then here we have the expiratory capacity, which is the maximal amount of air that can be expired after a normal inspiration. Our lung volumes and capacity. And again, I said functional residual capacity, residual volume, and total lung capacity cannot be determined by spirometry. We have other methods like whole body phlegmotesmography and nitrogen washout methods and helium dilution methods can be employed. We will be going through our analysis, and this is the table that you're going to be computing your results into, especially into this column, experimental and calculated data. Remember I said that the residual volume, total lung capacity, functional residual capacity cannot be measured by spirometry. The residual volume has a formula that once you have your vital capacity and you multiply the value by 0.25, then you're going to get your predicted value of residual volume using this formula, which is only valid for people around the age of 15 to 34 years. All right, I have promised to show you how to obtain data from the spirogram. So these are the results we obtain from the spirogram, and what I'm going to be doing now is to show you how I obtain these results, and then we further extract the information here into our table that I show you earlier. So what we're going to do now, I'm going to create a new blank document just for the purpose of this demonstration. So I'm going to create a new blank document. All right, now let me increase the font size. Spirometry data, let me just put it. All right, sometimes you can put the name of the subject. Just as an example, we are going to bring out our DVM. So this is our DVM, digital voltmeter. This one is showing time in seconds, and the fourth channel here is showing flow in liter per minute. So as I move my cursor up and down, it will be showing flow in liter per minute. The second channel is for volume, and this is measuring in liters. This channel measures minute ventilation in liter per minute, while this is the tidal volume, the overall tidal volume in liters, calculated for each breath. So, and this is nice. So first of all, we are going to be using an instrument called the marker tool. At the angle here, you can see this letter M is called the marker tool, which you can click on it and drag onto your data on the wave here. So if we decide to measure the inspiratory reserve volume, this marker tool will show us the difference between one point and another point. So let me close the rest of the DVM so that we'll not be cluttered with too many information here. So I'll only leave the volume channel since we want to calculate the volumes. So it will show us the difference between the two. Bring it to this point. So now we want to calculate the inspiratory reserve volume. We now place the marker tool at the top of the tidal volume before the forced vital capacity. And then now when I move the cursor, you will see another cursor that is moving on the wave. So it is called the waveform cursor. Waveform cursor. Volume here is 1.05 liters. This is IRV will be equals to 1.05 liter. Based on this subject, to measure our ERV, we're going to move the marker tool down to the trough, and then we'll measure this side. We have 1.5 liter. 1.5. If you want to bring back the marker tool to its original position, you click outside, the marker tool return to its original position. If you want to manually measure the rate of respiration, you can bring down the cursor. You either place it at the crest here, okay, and then you are going to the marker tool. This marker tool is going to mark that point as 0 when you look at the time. When you look at the time, it will, from this point is going to, before the marker tool is in a minus, when you bring it to the marker tool, you will see it will start from that point as 0. You are going to select some of the data for 15 seconds. You can select for 1 minute and then count the number of breaths in 1 minute. But in this case, if I select for 15 seconds, for instance, at 0 line, yes, from here, if I now select for 15 seconds, and if I multiply 15 seconds by 4, I'm going to get 60 seconds, which is 1 minute. So that means I will count the number of breaths in 15 seconds and also multiply it by 4 to make it 1 minute's value. So now for 15 seconds, I have 1, 2, 3, 4 breath, 4 to 5 breath. There's 4.5 breath, which is approximately 16 breath by 4. 4.5 breath time is, let's say 4 breath time is 4, which is 16 breath per minute. So that is how to use the marker tool to get your rate of respiration. Now click outside. Now if you want this channel to return to their normal position, you double click and they will return to their normal position. Now we can still expand. We have more attention on the flow channel. And remember, the rates of this channel are calculated channel is being calculated from the phase channel here. The flow channel calculated from the flow channel is the major channel that is measuring flow, inspiration and expiration, while these channels are being calculated from the force channel. So that is one important information that you need to know. All right, let's pick some of our data here. We go to zoom window and then we can see it pick out the data for us. Now we can copy this zoom window, extract it, and then paste it somewhere around here. So now we have our data here. So we continue to extract information from the PowerLab. So this is a graphical representation of our spirogram. Now we can now select one of the breath. Let me select one of these. And then we go to spirometry data. Yes, you can see force vital capacity in 1 second and then the force vital capacity. Nice plots. Let me close this. And here you can see the peak inspiratory flow and the peak expiratory flow. Now we can copy this window, spirometry data, and export it into our Word document. We paste it here. If you like, you can crop it and get the relevant parts. This is what we're interested in. So basically what you need to do with this data is to collect this information into a table. I have done the majority of the job. So what you are going to be doing is collecting this data from the Word document into a table in a PowerPoint presentation, and then you perform the rest of the calculation. This is the table that you're going to be filling in your information on, and you're going to fill in this column and then look for normal values to fill in this column. You're going to be moving data from Word document. You collect the information and fill it in here. This one with asterisks. Once you have them, you'll be able to perform the rest of this calculation with them. So you'll be on the lookout to make sure you get this information onto this table, and then you complete your calculation using these parameters. And same thing here, you're going to be moving the data from the Word document into this table and also look for their normal value wherever possible. So this is inspiratory reserve volume. So I'm going to copy it into my table. So inspiratory reserve volume for this subject, for your group. Then we paste it here. It's in liter. Then we go back to the Word document, copy for expiratory reserve volume, and transfer it onto this table. You can see there the one with the asterisk. So I paste it here and it's in liters. So continuously we'll move in here. For tidal volume, we're going to be using the average tidal volume for that the PowerLab has already analyzed for us. This is the average tidal volume. So I'm going to copy it and then look for tidal volume here. So you can put the approximated value here. So this one is, we've gotten this, okay, frequency, the rate of respiration. You just scroll down to the bottom of your data. So this is the frequency per minute. We have 22 breaths per minute. We just put the approximate value here, 22 breaths per minute. Once you get these 4 parameters, you perform the rest of the calculation and impute your normal values. The dynamic volume, you can see the table here for the force breath, where you perform force vital capacity. So you're going to be taking the information here, the time for that is procedure takes 2 to 3 seconds. So that will be the duration. The time, for the time, you paste it here. Increase the font size. You go back in again. For this one, you copy this peak inspiratory flow, you paste the data here. So where we are only interested in the one in liter per second. Yes, we're interested in the 1 liter per second. Interested in the 1 liter per second. Peak expiratory flow rate. We copy it here. Peak expiratory flow rate. You paste it, and we're only interested in 1 liter per second, just for you to see clearly. Then we have force vital capacity. So you just copy the information from this table to that place. Paste. So then you also copy force expiratory volume in 1 second. FEV1. FEV1. Make sure you format your data. This is the value that we use to know whether someone is having restrictive or obstructive lung disease. And all this information will tell us, give us more information about the patient or the subject. So we can copy this graph into PowerPoint here, and we arrange it, and you can even label it as spirogram. You can even put your group name. We already have dates. You already have dates there. You can put the sex of the subjects, even the height. It depends. You can even put the even age of the subjects. Those are some of, and you arrange them in a very good. You can copy this information into your PowerPoint presentation. You can say that this one is the force vital capacity and ratio, and then so basically these are the information that you need. So now you already have this information on your table. Now you can now go ahead and print out. Okay, make sure you print everything on a page. Print everything on a page, and it's going to look like this on one page. And you can make your comments or discuss your results. So I'm going to send the soft copy of this PowerPoint presentation to you, and the soft copy of the Word document to you, so that you copy the information from the Word document to this PowerPoint. And I'll only need the printed copy of the PowerPoint. The Word document, you don't have to print it. So, and you are going to print it on one page. Thank you for your time. Thank you for this moment. Thank you for listening. For more videos like this, hit the subscribe button below to be the first to be notified. Please like and share. And thank you for listening, and see you next time.